the magnetic effect of a steady current. So basically we're going to start our chapter 15th, which is electromagnetism. So basically the concept is that whenever a current flows in a circuit, there will be a magnetic field produced around that conductor, right? So whenever current passes through a conductor, the magnetic field is produced around that conductor. So we can take an example of a wire over here, okay, and some amount of current is flowing through that wire. Now, there will be some kind of magnetic field produced around that wire, and the effect of this magnetic field can be definitely felt whenever we take a magnet and just place it near to that electric field or the wire, of course. Okay, so what is the shape of that magnetic field? What is the direction of that magnetic field, and how can we determine the direction of magnetic field for different conductors or different flows of current? So first of all, the shape of magnetic field can be found out by using a kind of experiment where we can take a wire and pass some amount of current through it, right? So अगर हम एक वायर लें and उसमें से करंट पास करें and कुछ छोटे से कंपस लें, छोटे छोटे कंपस लें और उसको वायर के अराउंड एक सर्कुलर शेप में प्लेस कर दें. Then the needle of the compass will be so directed that they will all combinedly form a circle. Okay, as you can see over here, this needle directs in this direction, this compass needle directs over here. So they're not actually directing in a specific direction, just one direction. Rather, they are forming a circular path or a circular orbit, you can say. Okay, so this determines that the direction of magnetic field around a current carrying wire is in a shape of a circle. We can also prove it by using another experiment where we take another wire and pass some amount of current through it and pass this wire through certain paper. Okay, we have taken this paper and this wire is passing through this paper, and we have placed some amount of iron dust onto this paper or iron fillings around onto this paper. Now when current would flow through this wire, these iron particles or these iron fillings will arrange themselves in the form of concentric circles, just like this. Okay, this shows that the shape of magnetic field produced by that conductor is actually in a shape of in a circular shape, right? So as it is in a certain shape, so it must have some kind of direction, of course. All right, so the direction depends upon whether the direction of the current is to the upwards or to the downwards, or in one way or to in another. Okay, so we take a wire over here and take another wire over here. Repeat that experiments for both wires. We take some magnetic compasses and place them around this wire and do the same with this wire, of course. But what would we do is that we are going to provide current to this wire in the upward direction and current to this wire in the downward direction. Now what did we observe that is whenever we place these compasses around the wire in which the current was flowing in upward direction, they arranged themselves in anti-clockwise direction. But when we took the wire with the downward current, those magnetic compasses would arrange themselves so that they all point in a clockwise direction. So there must be some kind of rule to make this thing more generalized. The rule used to determine the direction of magnetic field um, due to current carrying wire is determined by the right hand rule. Okay, so the right hand rule says that if the fingers of the right hand are curled in the direction of magnetic field, then the thumb would point in the direction of current, or if the thumb points in the direction of the current, then the fingers curved around the wire directs in the direction of magnetic field. Okay, so keeping it simple, let's suppose this is the our current carrying wire, all right, and this is the arrowhead. It means that the current is flowing through this wire and the current is going in upward direction. So हमें कैसे पता चलेगा मैग्नेटिक फील्ड जो कि इस कंडक्टर के अराउंड जनरेट होगी वो किस डायरेक्शन में होगी. To find this direction of magnetic field, we have to use the right hand rule. Right hand rule says that if we take this conductor and grab it by our hand, okay, just like this, then keeping the thumb in the direction of the current, okay, if the thumb directs in the direction of the current, then the curl of the fingers, see my curl, and the curl of the fingers determine the direction of magnetic field. Okay, so now taking the opposite case, when the current is pointing downwards. Now what would we see is that my thumb is actually pointing downwards along with this wire, and the curl of my fingers, if you can see it like this, would point in the opposite direction as the previous one. Okay, so the direction would be reversed, of course. So this is the kind of rule that we can use to determine the direction of magnetic field around a current carrying wire. Okay, so by definition, you can use either this one or either this one, because you can use the right hand rule to either determine the direction of the current or the direction of magnetic field, of course. But whatever happens, whenever any kind of current passes through any conductor, no matter whether it's a wire or any kind of conductor, a magnetic field will be generated around that conductor, because these moving electrons will actually arrange themselves in a certain direction due to the flow of current. That is why the magnetic field is actually produced. लेकिन हम ये चीज़ें बाद में डिस्कस करेंगे. अभी basic concept just ये है that whenever current passes through a conductor, a magnetic field is generated, and the direction of the shape of this magnetic field is circular in nature, and the direction of that magnetic field can be determined by using right hand rule, which says that if you just grab that wire with your hand and the thumb points in the direction of current, then the curl of fingers points in the direction of the magnetic field. So this was all for today. Thank you so much, everyone.